Welcome to this explainer. Today, we're unlocking the black box of Claude Code's two absolute most critical settings, model selection and effort level. Look, if you've ever sat there watching an AI coding assistant confidently hallucinate an API that literally doesn't exist, or just bail halfway through a massive refactoring job, well, you know exactly how frustrating it can be. Mastering these two specific dials, it's not just going to save you major headaches, it's going to save you serious development time, and significantly optimize those token costs.
So it brings us to a really common developer frustration, right? When Claude Code gets it wrong, do you change the model or do you change the effort? Just blindly guessing which setting to tweak is kind of like throwing darts in the dark. It wastes time and, let's be real, it wastes money. Absolutely nobody likes explaining massive token bills to their engineering manager. You need to know exactly which lever to pull.
Okay, let's dive into this. Here's our quick roadmap for today. First, the engine. Second, lever 1, model selection. Third, lever 2, effort level. Then, troubleshooting. And finally, the worker analogy.
All right, section 1, the engine, tokenization, and weights.
To really get how these dials work, we got to look under the hood for a second. Whenever you use Claude Code, everything, your prompt, your tool definitions, your conversation history, your files, it all gets packed into one single API request. But here's the kicker. The model never actually sees your plain text. The very first step in the pipeline on the server is called tokenization. Basically, this is where your text is split up into little pieces, and each piece is mapped to a specific integer from a fixed, pre-trained vocabulary.
To ground this in reality, let's look at some specific TypeScript examples. The keyword const, for instance, might map to the integer 1978. A weight maps to 4293. From that point forward, your entire beautifully crafted prompt, it's just an array of integers to the AI.
Now you might be wondering, what actually turns these input tokens into probabilities? How does it know what to code next?
Well, the answer lies in the weights, which you might also hear called parameters. We're talking about billions of numbers organized into these massive matrices during the model's initial training phase. The model essentially runs your input through a really long chain of matrix multiplications and then just reads the probabilities at the very end. Now here is the absolute most critical thing to understand today. By the time you hit send on a request, those weights are completely frozen. They are read-only. Everything the model knows about TypeScript or Go or whatever popular framework you're using, it all lives entirely in these frozen weights.
Because of that, we have to understand the huge difference between steering and teaching. You can absolutely steer Claude, right? You can drop your real code or paste some new library documentation right into the context, and it'll use them for that specific request. But you are not teaching it. You literally cannot encode permanent, new knowledge into its frozen weights live in your terminal. So, if it tries to call an API that doesn't exist, it's not a failed database lookup. It's just the weights producing a sequence of tokens that, well, merely looks plausible based on its original training.
Moving right along to section 2, level 1, model selection.
So, shifting over to the tools you actually control. When you change the model in Claude Code, you aren't just telling the AI to be smarter, you are literally swapping out the frozen weights. You're swapping the entire engine. The model setting dictates what Claude knows and its overall capability range. This is exactly why larger models are fundamentally better at handling extreme ambiguity and super subtle bugs. They just have a larger, much more complex set of weights to draw their answers from.
Next up, section 3, level 2, effort level.
But what happens if capability isn't the problem? What if you just need the model to be a bit more thorough? Well, that's where effort level comes in, and this brilliantly illustrates the difference. While model selection dictates capability by swapping the frozen weights, effort level dictates thoroughness. It controls how much work Claude does on your request overall. See, the model doesn't just generate a whole answer all at once. It predicts one token, appends it, and loops again. Effort tells the model how thorough and how certain it needs to be before it considers the task done and finally stops looping.
So when you crank that effort level all the way up, Claude generates a lot more tokens to produce a higher confidence answer. Under the hood, it actually dynamically iterates through multi-step tasks. It might create a plan, read a bunch of files, execute some code, and critically, it will double-check and verify its own hypotheses. It's actually really smart about this. If, say, step 1 of a debugging plan finds the bug immediately, Claude will often just state that the remaining checks aren't needed and revise its task list mid-run.
But thoroughness definitely comes at a cost. A high effort path can generate roughly 7 times more tokens to reach a high confidence answer compared to a lower effort path on that exact same prompt. That's a huge jump, and it directly impacts your token costs. Because of this, the Anthropic team strongly recommends that for most tasks, you really should just start with the model's default effort level. It scales token usage based on what most people actually want to spend.
All right, Section 4, Troubleshooting, Fixing Wrong Answers. So what do we actually do when things go sideways in the terminal? Well, before you immediately reach for the dials, ask yourself this core heuristic straight from the Claude team. Did it not try hard enough, or did it not know enough? That right there is your ultimate fallback question.
To make it super actionable, here's your no-nonsense troubleshooting checklist. Rule number 1, always check your context first. Are you giving it vague prompts? Is it actually connected to the right tools? Now, if the context is rock solid, but the problem involves some totally unfamiliar architecture or super subtle bugs, it's too hard. You need a larger model. Did it know enough, but skipped a file, or didn't run the tests, or maybe just bailed on a refactor? In that case, it didn't try hard enough, so you need higher effort. Conversely, if you're just doing routine mechanical work or really simple edits, do yourself a favor and drop down to a smaller model to save money without sacrificing any quality.
Which brings us to Section 5, the worker analogy.
To really cement these concepts, let's look at how capability and thoroughness manifest across the specific models. Lydia Hawley, who's a member of the technical staff on the Claude Code team, framed the models with this brilliant analogy. She says, Fable is a specialist who's seen problems almost no one else has, Opus is the expert, and Sonnet is a really good generalist.
Now let's see how these personas map against our effort dial. Think of Opus at low effort as getting, say, 5 minutes with a deep expert. They're going to spot patterns really quickly, but it's just a fast read. Now give Sonnet, your trusty generalist, a high effort level, and it's like giving them the entire afternoon to read everything, run all the tests, and understand your specific codebase incredibly thoroughly. But Fable is your specialist. Even at a low effort setting, Fable will glance at a problem that literally everyone else is stuck on and spot the obscure bug instantly. And at high effort, Fable can finish grinding through the absolute hardest, multi-step, multi-file jobs that Opus and Sonnet simply cannot reach, no matter how high you crank their effort dials.
Ultimately, none of these models or settings are universally better than the others. It is entirely about matching the right tool to the task. The model dictates capability, and the effort dictates thoroughness. So I'll leave you with this. Next time Claude Code hits a brick wall in your terminal, are you going to reach for a bigger engine, or are you just going to press harder on the gas? Use the context we went over today, save your tokens, and happy coding.